You wanted to know about experience. Trade days.
You are ready to rock, Jeff.
I am Jeff Mattocks, Allied Equipment. So mainly hydraulic equipment. Talking today about expansion tanks. In a system, you always want your expansion tank to be placed on the suction side of a pump. And this is the reason, because you bring in your makeup feed here, whether it's a glycol feed unit or a PRV with a backflow preventer. This is your system no point of pressure change, they call it. And the reason being is because if you put the tank over here, when the pumps are off, I have one pressure, the pumps start to take the system to a different pressure. And that would flood your tank with a varying pressure. So basically, theoretically, your pumps are sized just perfectly. By the time they go all the way around the loop, by the time it gets back to this point, no pressure change, you're going to be just at your fill pressure. So the pressure is basically stable here, is why you want your expansion tank tied in here. You want your air separator, expansion tank, all tied in right here. If you have a bladder type tank, you want the air separator to vent the air off of the atmosphere. If you have a plain steel type tank, which are very rare anymore, you wanted that mounted at the high point, and you want all this air to return to that tank.
Compression.
What's that?
Compression tank.
Compression tank, yeah. Instead of a bladder, because the bladder has an air charge in it the plain steels don't. So we'll get into that in a little bit too. Here's just a picture of many different tanks. Here's the compression tanks we were talking about. This is just a plain steel. Usually it has a gauge glass on it. You'll have a drain, and then you have a device called a tank troll. And what the tank troll does for you is it allows the tube that goes up in here above the water line. And there's a vent down here, so you can open the vent, let air in as you drain the tank. It allows you to drain the tank, because over time, what happens when this is just atmospheric pressure. So when I first align this in a system, it's going to flood about half of this tank with water. And then you're going to have an air-water interface, and over time, the water can absorb into the air will, absorb into the water, and eventually you'll get with a waterlogged tank. So that's the downfall of it. We'll get into that a little more. Then you have a CX series, which is a bladder type, and then a CA type, and a CVX. And that's just our model number. Armstrong has the same thing, Gossett. So what it is the CX tank, there's a diaphragm in here, and we'll show that in a little bit. These are non-repairable. You have a diaphragm tank, they're less money, but if it fails, you've got to junk the whole tank. A bladder type tank, you have two different bladder type tanks. One is a partial acceptance and one's a full acceptance. And what I mean by that is in this tank, there's a hose that hangs, and there's a little bag in here. That's your acceptance volume this tank can take. You might have a 12-gallon acceptance and a 34-gallon tank. I'll get into that in a little bit too. The bladder, the CAs, or Bell and Gossett's B series, the bladder mirrors this whole tank. The bladder is as big as the tank, so you don't have that little acceptance or full acceptance volume. So I would take the pressure off this. It's a 158-gallon tank. I can put 158 gallons in the tank. This one I can only put in 12, even though it's a 34-gallon tank.
So that would be considered more for like residential, that deep
No, these are all ASME, 125-pound ASME commercial tanks.
commercial tanks. Okay, because that's just
The difference is these are less money than this bladder type tank. The one thing with the CVX or the CX, they have to be vertically mounted. The full acceptance can go horizontal or vertical. That's the big delineation between the two. Much larger systems, you're going to probably wind up with the CA, because I need the more acceptance, and these little ones will handle. These are just a lot more expensive with that bladder. So if I can use the small acceptance in a smaller tank, this is less money, and this is even less money with a diaphragm. But again, this has an acceptance volume and a full volume. And we'll get into that when we talk about tank size. And one of these, you have a full acceptance tank, but your actual acceptance is only about 90% of the tank. And acceptance means how much water I can put in the tank. So if this has 12 gallons of acceptance, 34-gallon tank, that means I have 12 gallons and 22 gallons of air. Okay, that's why you can never get 100%, because you have to have an air charge in the requests.
yeah.
All right, here's some terms to go over. BQ GPM 500 Delta T, that's a really nice thing to have. Somebody, you don't know what your GPM of a boiler is. So if I have a 10,000 BTU boiler, 20-degree delta T, this 20 times that's 10,000. You divide that into there, it's only 10 GPM. So you can get an idea of what GPM you need on a piece of equipment by using that, by the BTU rating, with 20-degree delta T, you can divide it out and know how much you need to set your balance out for. Side view rule of thumb, this only works on the full acceptance bladder type tanks as I was talking about. If you take the BTU divided by 15,000, that'll give you a rough size of a compression tank. Okay, the atmospheric one. And if you multiply that by roughly times 0.55, that'll give you the volume of a full acceptance tank. So if you have a large plain steel tank, the bladder type tank is going to be much smaller volume. And the difference is because the atmospheric tank only compressed against 12 pounds. And we'll get into this in a minute too, but when the acceptance, we charge that tank to whatever your fill pressure is full of air. I'll talk about that more in a minute. So again, like I said earlier, plain steel connect to the top of the air separator. You want all that air to go back in your tank. As it waterlogs out into the system, you want the air separator to put it back in the plain steel compression tank. Diaphragm, you want to get rid of that air. You don't want it going into the tank. You want the water in the bladder and air on the outside. You don't want any air in the bladder. Okay? And the diaphragm, same thing. It's non-repairable. Got that bladder in the middle. We kind of talked about this partial acceptance, full acceptance. We kind of went through that. As far as the state of Ohio goes, anything over 199,000 BTUs input is required to have an ASME stamp on your tank. It's a requirement by the code. You can't use, I don't know how many times I've been on jobs that went out and there's a Amtro, AX, whatever, without the C, without the V, and they're non-ASME, the inspector will red tag your boiler to shut you down. He sees that. They have to have that ASME rating over 199,000 BTUs. That's why you see a lot of water heaters that people make. They just happen to be 199,000 BTUs. Why? Because they don't have to be ASME then.
119 gallon tanks.
Right, exactly. And they put 4 of them in together, they could still be non-ASME. But if you put one big one in a million, now you're up to ASME more money. And all ASME does is we make them at different code pressure ratings. And all ASME does, the manufacturer has an ASME inspector on site at all times. They're certified to make ASME tanks, and they track the paperwork on that tank from birth to death. Where the steel came from, the quality of the steel, how the welds are made, everything is documented. It's, but there's a cost to it because they have to catalog all this, save all this data, and they have to have an inspector inspect it. And if you ever look on a tank, you'll ever see a little, looks like a 4-leaf clover with a U in the middle. That's the ASME stamp. That says this tank is certified. For example, we make plumbing tanks, the PAX series. We make, this is for NSF. Lead-free.
Food service.
What's that?
Food service.
What for domestic?
Yeah.
But the difference is I make a PAX 84 that's non-NSF certified. It might be $1,500. You get the Dash P, which has an NSF certification 61 certified, same thing, but with the paperwork, it's about $800 more. So, and that's the same way at the ASME tank. That's why a lot of times people over 199,000 use a non-cooked tank because they're much cheaper because you don't have the paperwork trail. And it makes it more expensive. You agree with that?
Yeah.
Okay.
I've had some guys come back though and tell me that 199,000, but it has to be 30 psi or higher than 30 psi. Some guys will go with if it's less than 30-pound relief valve, they don't ask for an ASME.
Right. Well, the code change, it used to be when we first started, high pressure piping remnants as anything over 30 pounds,
right,
which was a real pain in the butt because when you size an expansion tank, you use your full pressure to your max pressure.
Mm-hmm.
So my tank has to be size of a Volkswagen,
right,
to work on a system. Now they changed the code, 125 psi above is high pressure piping permit. So now I can size my tank to go from 12 to 120 psi. My tank's a third of the size of what we used to have to provide to keep that from going over the pressure.
And when you get so say if you did spend the money in that, does that mean that has to get like a yearly inspection
No.
then too? No, it's just
No.
a one time.
But I can go back to my manufacturer 10 years later and say, here's my serial number. What tank is it? So go, that's a PAX 125.
Okay, so
They'll have everything and they keep their records, like I said, from birth to death.
okay.
And it has all the material, where the materials came from, the steel, quality of the steel, the welds, and there's an inspector standing there. Yeah, it's ASME welded, Stanford. And it's just like in anything ASME, if you get a tank in the field, let's say even a storage tank, it's ASME, you pop a leak in it. You can't patch that tank without an R1 stamp. The only people can fix that tank or you avoid the ASME code. And there's people that are trained that get an R1 stamp. They have a little, and you need an R1 welder. He can field stamp it and recertify the ASME. The tank will hold the ASME. So if you're ever seeing anything with an ASME stamp on it, for example, once I build a package, I have one of the contractors build a pump package for me. And there's my ASME air separator sticking way out in front. And they mounted it very nicely with the welded angle irons to it. Well, they just voided my ASME code because they welded it without an R1 stamp. Even though they didn't penetrate it, once they touched it,
It's done.
it's done. Now they can weld on the skirts, but it's not part of it, it's not in it. But if you touch the shell of the tank, it's like great. So anyhow. What else? What more to me? Oh, there it is. Okay, now we talked about the point of no pressure change. Now, when you do a fill pressure of the tank, this comes up all the time. People go, what should I fill my system to? And what you want is plain steel tanks is atmospheric, but any fill pressure, what you're trying to do is push the water to the top of the building. And you want a pound or two on the top floor so you can vent. So to make it easy, every 2.31 feet is 1 PSI. So if I have a 23-foot tall building divided by 2.31, I need 10 pounds of fill pressure just to get that water to the top of the loop. And then I want to set my fill pressure to 11 or 12 so I'm positive then. Because then when your pumps take over, the fill pressure fills your loop. The pumps only overcome the friction. So no matter whatever your height is, divided by 2.31, that's your pounds per square inch, and add a couple pounds. Then when you have a plain steel tank, it's going to flatten that water in the tank. A bladder type tank, you want to charge it, the air charge, without water pressure on it, to that same exact pressure. Because what that does is I have 12 pounds of fill pressure and I've got 12 pounds of air in my bladder. The tank is empty. There's nothing can get in there. And once the water starts heating up, expanding, the pressure is going to go up. It's going to force water to migrate into the tank. And then when it cools, it's going to push the water back out. A lot of times I'll get people to call me, oh, I'm lifting relief valves. Have you checked your bladder pressure? Oh no. Well, disconnect it from the system. Don't check it while it's live. Isolate it, get the water pressure off, check your air pressure. If that's not equal to your fill pressure, what happens is I have no air pressure and I put 12 pounds of just like my compression tank. All that water is going to come in and equalize 12 pounds and fill 3/4 of my tank. Now I had an 80-gallon tank there. Now I've got 20 gallons of expansion. Won't work. And if you start lifting relief valves on a bladder type tank, first thing you want to do also check the air pressure and then check your Schrader valve. If you push that Schrader valve, you only want air to come out. They all have them, they're hidden. Looks like a little fitting on top, looks like your car tire. Press that. If you get water, good stream of water out of your bladder is broken, your tank's just a piece of pipe now. And you need to replace that bladder or replace the tank. If you only want air and then get the water pressure off of it, break it. That's why a lot of times I tell people we make a little ball valve with a drain on. Put that on your makeup. And then you can isolate the ball with the drain valves over here. You can isolate the ball valve, open the drain, put a hose bib on it, drain the water, let the water pressure come off the tank. Then you can just check your air. I don't care if there's water still in the tank. I just got the system pressure off. Okay,
And that's a mistake that a lot of guys, make.
exactly.
They'd say, oh, I got this much pressure in my tank, but I said, are you still connected to the system? Oh, yeah.
Yeah, well, you don't know what your pressure.
You don't know what your pressure
It's
is.
gonna equalize with your water pressure, whether it's got zero air or no air or a lot of air. And a lot of inspectors will ding that valve. They don't like having that valve, see, people can't isolate your tank. So most of them that I know will accept, take the valve handle off, put it on a wire and hang it next to the tank. It's there if you need it, nobody can, and most inspectors will. Cause you can't accidentally hit it, but
I did that once and the lady who was the inspector said, why'd you do that? Cause I'm not supposed to have a valve here that somebody can blow.
exactly. And then into your expansion tank, and then you liquid. But if you ever get a call on a lift in relief, the first place to go is your tank. Hit that Schrader valve. Oh, I'm getting water. We're done. We know what's wrong. I'm getting air. Now disconnect the tank, lay it down and check your air pressure. Now, one thing, when let's say you do lose all your air, I got it, 158 gallons of water in this tank. You broke it from the system, or have my little ball valve open. When you charge that tank, leave that ball valve open. As you put air into that Schrader, it's going to collapse that bladder and force all that water right out of the tank. It's going to eventually go flat and push everything out of that tank. You don't have to turn the tank upside down and try to empty it. Just put your air to it, and it'll collapse that bladder, and the water will start rushing out until you get your free charge. And then just reopen your tank back to the system, and everything should be fine.
And I'm sure Jeff would recommend too, when you get a tank, even though the manufacturer says it's charged at 40 PSI, or whatever, always check it.
And the other thing is, all tank manufacturers by shipping code. A lot of jobs in there, they want your fill pressure. You might have an 80-pound fill pressure in tank that you need for the height of the building. Every tank you get's it says a sticker right on it, charged at 12 PSI. The reason they do that, the shippers are not allowed to carry it with more pressure than that, because it's a hazard. So when you got a tank, yeah, they'll all come with 12 because it's tag on it. And that doesn't mean that's what you're supposed to do. You know, well, it's just 12 PSI. That's great if I got a 10-story building, 20-foot story, 23-foot tall building, I'm good. But if I got a 100-foot tall building, let's say it's 231 feet to make the math. So what pressure do I need at 231 feet? Plus,
You're calling.
no, plus a pound.
Yeah.
So I want 102. So what air charge do I put in my tank?
102.
There you go. But it's going to come full PSIG. And the problem is when you put 102 pounds of water pressure on that tank, you're going to fill that tank up 90% of the way your fire boilers are going to lift your leaf off in the first 5 minutes. And that has nowhere for that expanding water to go, and your pressure just goes astronomical. It's just crazy. So all your tanks are all going to come, they'll never come with those 12 pounds. The truckers won't touch them, they're not allowed to. So that's why you get them at 12 pounds. Every tank in my warehouse is 12 pounds.
I did not know. That was interesting.
Yeah. You always want to check it, figure out what your fill pressure is, air charge that tank, and then put it on the system.
Yeah, 12 pounds for the truckers, they would not.
That's what they do it, because they don't want a 100-pound tank exploding.
Their truck.
Somebody hitting it with a forklift, it'd be ugly. But the truckers never damage any work, but. That's it. You ever had any trucker?
Oh, no.
No, never. I've had a horizontal split case pumps that when they came in where they looked like they rolled down a mountain. Just terrible. But anyhow. And again, we talked about this with being the compression tank at the high point, your bladder. Anyhow, your compression tank, high point, air goes back, compression tank. And then when you pipe to a tank down on the ground, a bladder type, the last 90 you make, that you go to the sea, come down from the ceiling, come over and drop to my tank. At this point right here, I want an automatic air vent. So if any air does migrate down and wants to go in my bladder, it gets fed off. Always put a little 418 or a main of the mist, something little automatic vent. So right at that last 90, and it can be a little half inch Just because there's not a lot of air, the water migrates, but water can migrate with air in it and release it on that last bend. You want it out of it.
Well, which air event do you guys recommend that?
What's that?
Which air event do you?
I can take a 418. It's a 3/4 male by 1/2 inch female, 125 pound rated, and you put it, just put a T there at the last break and put your automatic air vent right before you go to the bladder on bladder pipe.
Yeah.
And then plain steel, you want to pipe back to that troll and let that air go back. You don't want it to go outside. Okay? This is an example of a plain steel. Like I said, I'm just operating wood here. On the plain steel, if you ever see a gauge glass, that's a dead giveaway. It's a compression tank. There's no pre-charging in tanks. This is the tank troll I was talking about. It looks like a little iron fitting Belagas, an ATL or whatever. They all do the same thing. And there's what the troll looks like. Here's your vent. So if I were to drain this tank, over time, the air will absorb into the water. The tank will get full. You start lifting relief valve. You go up, your gauge glass is full. So you isolate the tank. There's a drain on one side of the tank, or the new ones have the drain built into the troll. Open your little air vent and open your drain. It'll allow air to come in while this is leaching down. And that's the whole idea of the troll.
So the experience will tell you that tube plugs a lot. So if you can't vent the tank, you close the bottom sight glass valve and you open the drain on the sight glass
You can do that too.
and then vents.
Say
Or
Then you can crack the top sight glass open and let the air come in out there.
or the nut
there.
on the top of the sight glass.
But they're just baffled, and it gives you this tube that's just, because what it is a tube in a tube. It allows air to go out of here and water to go in the outside of it to go out the drain. So
So we all used to make different sizes for different tanks.
they still do.
Most of them went to just one size, and now you gotta cut.
You gotta cut them.
So you gotta cut.
Well, ours come with extensions for bigger tanks. We actually offer a 3/4, a 1, and an 1.25 inch. And they all have an extension tube, and if they're too small, you have to cut it absolutely right. But it'll it'll tell you exactly the 16-inch diameter, cut it to this, 20-inch tank,
Right,
cut
but
it
I'm
to this.
just saying that a lot of times
Right, 36-inch tank, put the extension on. It's all your O&M should tell you. You're absolutely right. Again, we talked about this, here's empty. As soon as I put fill pressure, it's gonna flood until it compresses that 12-pound air to equalize whatever my fill pressure is. Then over time, it's gonna eat this up, and then you're gonna need to blow it down. You call it a waterlogged tank. You get a call, hey, I'm looking ready, but you go and look at the sight glass, well, it's full. You'll never have that problem with bladder tanks. Everybody likes bladder for a lot more money, but they're a lot less headache.
But if you just go and open up a drain and think you're gonna get water out of that tank, you're not.
No, that
Because
wasn't
if
that.
you don't get air in, that water isn't gonna come out, and you might get a little bit of water and think, oh, good, I got a gap in there now. You don't, you gotta get air in there.
I've seen people just pipe them with a T going in. The problem is without that troll, you can't let the air in without messing with the gates. Let's say gate lines. Now you got water everywhere. So.
I've seen systems that have building air compressors.
Oh, yeah, attached
To the top of the tank.
Yeah.
Oh, yeah.
Yeah.
Oh, I've seen people you can put nitrogen bottles on them.
Yeah.
You can do.
But the thing is that if you got pressure on that tank and you're popping your relief valve, and you put air on top of that tank or nitrogen, what's the pressure gonna be? So it's gonna increase even more, right? So you gotta drain the tank anyway.
But again, this is the CA, they're usually on the floor. You can put this up here at the high point. Okay, but if I come out of this air separator and I turn to go up to that tank, what do I want right here? My CA tank's up here. What's it right there? If I put my bladder tank up here, guess what I want? My last 90 egg right here. I want an air vent there. I want the air to go out. I never wanted to go up to the tank. What you want to do is come in, make like a trap. Put, trap, and then go up and put your vent at the top of the trap. Just come over down and then go to the CA tank. So anything goes in there the water has to go down and up the siphon and let the air vent out before you go to if it's not on the floor. But again, right there is that vent. And so you want it. Any questions so far? Comments before this one? I don't know what this is for. Oh, they're talking about air versus compression tanks, you know. You get rid of the waterlogged tanks for the bladders. They reduce sizes up to 80% because I have that pre-charge in there. You know, this plain steel have to have so much more of atmospheric pressure. Reduce sizes, they're just much better. And again, this is back to if you're doing multiple tanks, shows you how to do them. Here's your isolation valve, talk about taking the handle off. Get ahead of myself here. Some of this. Now, here's a good example of this is your plain steel tank. Remember, I said use that factor of 0.55. That's the difference. Here's your captive air size. Here's your plain steel size, 515 to 158. Much smaller tank. But this is only 14.7 psi when you start. This one might be 30 psi charge. So I don't need as I can compress that air. I get a lot more air in that tank compressed than I can in atmosphere. So I need a much bigger tank to do it as a plain steel. But that makes sense. Plus the waterlogging issues. So again, if you go out in a job, there's a 100-gallon tank sitting there. What was my rule of thumb? 100-gallon times 0.55. You need a 55-gallon full acceptance bladder. Don't get one that has a partial acceptance. We'll get that out of the more, but you want a tank, CA type tank, or what was Armstrong's? I can't remember their model.
The L series.
The L series. And Wessels is an NLA, and Bellangasse is a B. They're all full bladder. You want to replace it with a full bladder, whatever that is, because you don't know what your acceptance is. And that'll protect you. And that 5.5's got some fudge in it too. You're not going to brass tacks, but if you have a 515, I don't need a 515-gallon bladder tank. It costs a fortune. So, and again, this is what I've been talking about with that air pressure. The expanded water compresses that air. Now, here's the other thing people say: oh gosh, I started at 15 pounds. My system's up to 95 pounds. We have a problem. I say, what's your relief valve setting? 120. You're good. Your system's rated. What's your system rated? 150. All the tanks do, they don't keep the people expect it to not gain pressure. That's not what they do. They're designed from coldest temperature to hottest temperature to lowest PSI to max PSI to keep that from lifting your relief valve. That's all they want to do. So when I'm going from 40 degrees still cold water to 200 full wide open boiler, my boiler, the pressure is going to go up. And as long as I don't lift that relief valve, I don't care. Because it's all static. My pumps are here at 14 psi, at 12 pounds of fill, they're adding 60 feet ahead. At 120 psi, they're still adding 60 feet ahead. My system can handle that pressure, it's not a problem. It's going to do that. And then as your firing rates decrease, the system temperature, like especially if you're running a reset, you know, when I'm at 200 degrees, I'm at 120 pounds. When I come back down to 100 degrees, my pressure is going to be down to 20 pounds again. It's because the water is going to expand and the tank's going to push it back in, heats up, it's going to take that, it's just going to control your pressure rate. So you don't let your relief out. That's the whole thing, that's our whole sole purpose of life. To get one that would hold the pressure equal, it wouldn't fit in this room. It'd be huge. So
Vince, these numbers are arbitrary.
Okay.
yeah, well, I'm just
I know. Making sure Vince understands.
now this is a diaphragm tank. This is actually what's in this tank right here. Your air charge goes on the top side, your water goes in and out of here. This diaphragm works just like your diaphragm here. It goes like this. And the compression that folds down, it just works like a diaphragm. Throwaway tanks. You break this, then you scrap it. You can't fix it. They're less money, but they're disposable. They are RSES, unique code. It's just what you want to do. This is when we were talking about the partial acceptance. The tank would be here. There's this hose that hangs inside, and this is connected inside that tank. That's the bladder. That, like I said, it might be a 120-gallon tank with a 45-gallon bladder. The acceptance is only what that bladder can hold. If you push that too far, you end up blowing the hose off them, or you could break the bladder. For the CA tank, see the bladder there? It's the full, it mirrors that tank page. And this is your gasket. This collar lays up on your flange here. And this is actually your gasket on the lid, between the lid. That's your actual gasket as part of the bladder itself. To replace these, it's not easy. The job,
I say they are replaceable, but they're not.
they are replaceable. And what you want to do is when you get in, and get the other one out, I always tell people to chain it down somewhere, get a chain pull, get a strap around that collar, and you have to winch it out. And once you get it out, this is still on its side. Make sure the tank's clean inside, inspect the tank, make sure there's nothing sticking out. One time at Tower City, they had the big CA 1200, they kept losing bladders. They looked down in there and there was, when they hit the weld, there was a piece of weld rod. They kept poking the bladder. That was a warranty. But anyhow, when you go put them back in, what you do is you take it and roll it up like around a 2x4, really tight. Push it down in the hole, you jam it down in the hole, and then kind of spin it free. And then what you want to do is air charge that tank, let the bladder roll out. But you're going to charge it to the water connection. Because your air connections, there's a hole right here's your air connection. There's usually a screw, little cap on it. That's where your Schrader valve. Now that puts the air around the bladder. But when you're replacing the bladder, I want to put air in here to get the balloon out, get it to open up in that tank. Then you take the air pressure off of this, put your lid back on, connect your water side, fill your air charge, and then line it to the system. And I've done a bunch of these on domestic systems, and they're very nice. Algae, green, slippery, you get pretty dirty doing those.
So caught for a couple of weeks.
Yeah,
Is this basically a dying breed of a tank rebuild? Or is it still like common practice?
we sell some bladders, but what it's gotten to is, let's say this is a $6,000 tank. The bladder's $4,800. The bladder is 80% of the price of the tank. So
that's what I was getting.
a lot of people
Cost
say, by the time I have two guys go out there and spend $3,000 on labor, send me a new tank, but on the smaller tanks, remember the diaphragm ones? So it's much easier because once you take the lid off, you can pull that little bladder out. It's on a hose. It's very easy to do. These are a lot of work because they expand to that, they mold to the tank and they're a pain to get out. And then you got to get them back in, but if it's because they'll show you on the tag, it'll say acceptance volume forward. Then you got a bladder. Those are much easier to do. And some of the new Wessels tanks, they've got the big lid on top and they hang down in there. Those aren't too bad. But these that you have to ram, this bladder has to fit through this plant.
That's a thick bladder too. It's not, it doesn't just, it's not something you just,
This bladder has to fit through that hole up here.
yeah, it's got some.
So
I mean, that's like me trying to put the tube on my motorcycle. Like, no, I just give somebody $50. Here you go. I don't, no.
and here's another bladder again. That's a
In-house will never change the bladder.
now.
No, it don't make sense.
Now, see, this is a CBX bladder. See, it's not the full size of the tank. Much easier to get in and out here. This only goes to like here in the tank, not mirroring the tank. So it's got the hose and the bladder that hangs in there. These cannot go horizontal. They have to go vertical. The full acceptance can go horizontal or vertical. Yeah, like I said, look for acceptance because a 32-gallon tank, I made two tanks. They both have 34 gallons of volume on the CBX tank. But one has a 12-gallon acceptance, one has a 20-gallon acceptance. So if you just say, well, it's a 34-gallon tank, if your system's big enough, you exceed that acceptance volume, it's not going to work. That's why we say if you use that rule of thumb, use the full acceptance bladder, can't go wrong. When you do the sizing, like on the computer program, it'll tell you, you have 12 gallons of acceptance expanded water, and you need a 34-gallon tank. Then you know exactly what you're getting because you know your volume and you did the count. But just going out in the field, you find a 36-gallon tank, only replace it with a 36-gallon full acceptance. Unless you can see with the acceptance and match the acceptance and the volume. You can always go bigger, but your acceptance is low, you'll blow that bladder.
The trouble is when you have to, in the field, size an extension tank. Like Jeff said, you have to know minimum pressure, maximum temperature, maximum temperature. You also have to know water volume. We're trying to calculate water volume.
That's coming.
Oh, okay.
That's okay. That's okay.
Lead into it.
I like group participation.
Segue.
But anyhow, just be careful. Look for that acceptance. This is what they're talking about. Like I said, they could both have acceptance of the same, but it could be two different volume tanks. And if you don't have enough tank for air pressure, it's a real high pressure, then you're screwed. And if you got your bladder's too small, you're screwed. So, this is the calculation. I'm not going to go into all the math, but again, you can see we always look at the volume, the lowest temperature, the highest temperature, atmospheric pressure plays into it. Specific volume of water, whether we're doing glycol or pure water. This is the equation of how you do it. My recommendation, TACO's got a great sizing program. You go on TACO Comfort, or you go on Bell and Gossett Sizer, or Armstrong. They all got a nice little program that'll ask you, just like Steve said, what's your volume? What's your fluid? What's your heating systems? I always use 40 degrees for fill temp, 200 degrees for max temp. Whatever your fill pressure is going to be based on your building height, you know how to do that count. And then go 5 pounds below your relief valve setting. So if my boiler's got 125, I'll go 12 psi filled to 120 psi for my tank side. I don't want to lift that relief valve. Relief valves start lifting 5 pounds below. They'll chatter. So you never want to go to the full 125 because when that tank is maxed out, you're going to be pushing that relief valve. So you may want to go a little lower than that. Just make your tank a little bigger, give yourself a little fudge factor. But all the manufacturers' programs, they've got a little fudge factor built into them already, but they're very easy to access. All the manufacturers have it, and just go in there and you know, guess at your system volume, or use my BTU rule. You know, divide by 15,000 times the 5.5. That'll protect you.
So that's kind of what I was getting at. Your rule of thumb is good because it's hard to calculate water volume in an existing building. If you don't know all the pipe sizes,
If you got a 120-year-old building.
You're gonna-
water.
If I go by BTUs and use my rule of thumb,
Yeah,
and get a
that's-
C8 tank, you'll be good.
Exactly.
I've never had one not work. Yeah, I've never had one not work yet. You know, I've done a lot of guesstimates and we've never had one with an issue.
But no, just to back up real quick, so you said your rule of thumb, you stay under 5 or whatnot, and so that way you don't not getting chattering, but you said in the program's already got the fudge factor, so is their average fudge factor 5 as well, or is that
No,
just you?
I would not run one above that. I don't know what the budget factor is with manufacturers,
So
But I never want-
5
but I never.
under there.
Let's say they're dead on. I don't want it to go to that 5 pound point, above that 5 pound point.
Yeah.
I want to make sure I'm below that 5 point.
Well, that's what I'm saying. So when you do their math, when you do the math, plug it in on theirs, then you want to do, say, 5 under that number,
Correct.
and then you're,
Yeah, you want to put in, if your relief valve is 125, put in 120. Relief valve is 150, put in 145 or 140. As your max pressure.
Yeah.
And then you'll never exceed that and push that relief valve at all. They will chatter and spit, and then after a while they'll fail because you're ramping up and you're right there. You want to just give yourself a little cushion.
For discussion, if we go with a 15 or 20 pound less than the 125.
Better yet,
All we're gonna do is increase the size of the tank.
you're gonna cost your owner a couple bucks.
Which is the right thing to do for us.
Correct.
okay, and that's what, because that's where I was.
What I was saying is that's the maximum for 5 pound pool. Anything below that, A lot of times you could even size them 12 to 75, 12 to 100, and you got 125, so like, you're golden.
As a general rule, Jeff, would you agree? You can't really oversize it.
No, we cannot.
So if you guess and you're conservative, you're only gonna help yourself out.
It just costs, the bigger the
It
tank.
gets cost more money.
That's the only,
Let's say, so it's a little bit of money right out the get-go, but you're protecting yourself and your client.
Absolutely.
you're not replacing relief valves twice a year,
And
$300 a pop.
I mean, that's the whole reason why we're out there. So, okay.
Let's say always err on that downward side, whatever. So anyhow, if anybody wants to do the math, there it is. And again, this is a more easier equation, doesn't quite, this gets rid of a lot of the viscosities and thermal calculations of the fluid. This is just down and dirty. Basically, this is how my program is gonna size it at paper, plus a flex factor in there. So it's gonna, use your fill V1's fill pressure, V2 is your max pressure. Then you have your P1, P2, V1, V2. And all this is gonna, you can just do what we said, and it's all in a program, you don't have to mess with this. You can just, this is what they're doing, this is where it comes from, correct? Right here's the program, see, right here, they're gonna ask you, what liquid do you have in water? Copper or steel, because that plays into the expansion of the pipes.
Yep.
System volume, fill operating, I always use 40, that's your city makeup's typically 40 degrees. You use water. Your max design temp, you fire your boilers to 200, that's what you want to put it. Fire to 180 and 180. Fill pressure, 12 psi. Max pressure, at least 5 pounds below the refill setting. And then you hit search, and it's going to pop you out a plain steel selection, a CBX selection, PAX selection, a CA full acceptance selection, and be careful because you'll like go in there and go, oh, I have to have a CA 800. Oh, look, it's like I have a CA 215. Look to the left, it said 3.
Yeah.
CA 215, CBX 2. Well, it's much smaller, yeah, but he wants to hear those versus one of those.
Yeah.
So just be careful. Like here's the selection we made here. See, it's saying I have one CA 140, one CBX 254, CX 300, PAX, and PSA. So again, CA 140, that's a full acceptance tank. CBX, that's the diaphragm. I mean, the bladder tank. The CX is the diaphragm throwaway tank. This is a domestic water tank. The PAX, it has a stainless steel connection, NSS certification. That's the difference. PSA is your plain steel. So I'm going from an 80-gallon plain steel tank to a CA 140, that's only a 23-gallon bladder versus an 80-gallon plain steel.
So are they going from the most expensive tank down to the cheapest?
No, it just pops it in there.
Out of it, that's how.
Price wise, cheapest, plain
Cheapest
steel,
at the bottom.
CX next, CBX next, and this is about
About the same.
because of the NSF and all that stuff.
Okay.
And the
all right.
stainless connection. This is most expensive. Most times I would go with this. Because a lot of people want to replace the bladder, but if you don't want to replace the bladder, why not buy the CX? You're gonna throw it away anyhow. Why spend an extra $1,000 down when you don't have any intention of replacing that bladder? Save the $1,000 up front, it goes bad, you buy another CX like. These, like you said, these aren't too bad to replace, these are a bitch to replace. And you can save money up front by going with this. It's ASME, everything means, but we can't do it. So it's just a matter of others, yeah.
Now, what about if you got, like, say, if you've got chemicals and all that in your system, would you still go with that one, grow it? Or does that even, does that bother you at all on any of them? On your choice?
Like the static.
What's that? I'm sorry, I missed that. What was that?
So so say you've got, chemicals or glycol, whatever you got in the systems, and say, when you said, okay, I would suggest this, because, well, it's bladder, it's a throwaway, like bang for your buck.
For sure.
But if you had those chemicals in, would that change your
recommendation on which tank you would have used.
When I come back to that, it asked you at the beginning of using water.
Yeah, and that's the reason why I'm
There you
asking.
could put in glycol, propylene, or ethylene, the percentage, and it will account for that in that calculation.
And then that'll limit your,
It'll just make a new selection,
okay,
because the expansion rates are different.
yes, so,
But are you referring to like a chemical action that destroy something in the tank?
No.
That's kind of what you're looking at?
The only nice thing with the bladder is it does isolate your water in the rust, the
Yeah.
touching metal.
You're not
Plain
touching.
steel over time will rust. But the chemicals aren't gonna bother the rubber bladder.
But what we see in our heating systems, it's not an issue.
yeah. I mean, I've seen, all different directions with that, but,
Quality of water, yeah.
but I just thought, well, since you're here, hey, let's ask a professional, what is your opinion on that?
Yeah, it's. Let me get rid of this little thing that popped up, trying to sell me something. Okay. I have to do what's good thing.
I think it just wants you to start talking about them boats again.
Okay, we're back. We're back. But anyhow, like I said, this. There's your number of tanks and what have you, like I said, it's all based, but here's what I want to show you was. Here's where you put in water. If you click the drop down, it'll ask you propylene glycol, ethylene glycol, what's your percentage of concentration? It doesn't make a difference. To tell it what liquid you're using. Here's like a cross-reference chart, you know, all the different manufacturers. A Taco CX is equal to an Amtrol AX, so Bell & Gossett, Don Woods, Wheat Leader. And they're just different kinds of tanks. So one's for partial acceptance and the other one's for the full acceptance cross-reference. Here's everybody's manufacturers. You see those Eagle People Armstrong right here,
I'm with you 100%.
But the new.
I got no allegiance, man.
But anyhow, so you can see you can cross, but the full acceptance is no worries. A B200, like a Bellingham B200, I think it's 200 liters. My CA250 is 215 liters. My CA number, that's a 500 liter tank, 132 gallon. Bellingham is 500 liter, 132. B&G, Amtrol. Your full acceptance. And whether you have one of mine and buy one of these, it's going to be this one. As long as your acceptance and your total volume match, you're good. These are the 61s I was the PAX tanks. Like I said, we make a PAX with a dash P at the end. That's NSF certified. Without the P, it's not certified. They're both made of the exact same materials. They're absolutely identical tanks. One has the paper trail saying I have a certification that I'm guaranteed certified lead free. Not the new buzzword is, oh, we're NSF 61 or NSF. These are both different lead specs. This one's much more stringent. This is what we use, NSF 61. They'll say we're NSF 61 compliant. Inspector comes in, it won't fly. You have to have that NSF 61 certification. But the difference is, like I said, my PAX without the P doesn't have that certification. It's about $1,000 cheap. But that certification costs a lot of money to get. We have to send 20 tanks out, they blow them up, they tear them apart. Independent person has to go through so many of them, so there's no lead. And that costs money. And again, this is like ASME. They maintain the paper on every tank, work with that, it's lead free.
So basically, that would be California rated, and this is, Mississippi rated then.
No, this is the new national standard.
Oh,
NSF 61 C72. They first came out at 372, which allowed like 2% lead or something. NSF 61 said no lead.
no, so,
Absolutely none. And But all your fixture manufacturers, and everything went up double in price because everybody has to meet. This is the national, there's a national sanitation foundation, whatever, and that's their regulation saying there is absolutely no lead. We make booster systems that are NSF 61 certified. They certify the whole packages of no lead. But I've seen some of my competitors were NSF 61 compliant. That'd be like selling my PX tank without the P. Yeah, it's compliant. But I don't have that certification. It costs money to, it costs you more money. Same thing. It's more money because of that cert. But I can give you a piece of paper you can hand to the inspector that says, this was inspected by, the third party says we're lead free. They don't take our word for it. We have to get third party justification. So this is all about NSF 372. Like I said, this was a lower first one that came out, and then they went to 61. But a lot more stringent testing conditions, less allowance of lead, and all this has to be done to get that certification.
It's National
What's that?
National Sanitation Foundation.
That's it. And that's what the PAX look like. They look just like my CBXs because they're top mount, top connection, but they also have a stainless connection right here. So when you go to hot potable water, not corrosive, it won't eat itself out. That was iron to be gone in here. One time years ago, I had an old house and I put some baseboard, and code came out and said you can use your domestic system to run heating. So I thought, well, this room's cool. I'll run some pipes up and I'll run the baseboard around in my room. Oh, that's nice. Couldn't find any brass tees. I'll put some iron tees in. They'll be good for 5-10 years. Less than a year, they were crumbling in my hands. Domestic hot water is so corrosive, and it allows conductivity transfer of electrons in order to heat up iron. That's why anytime you need a recirc pump for domestic, it has to be brass, bronze, stainless. Everybody's using stainless now for the bronze, that's what it goes. And lead issues. Stainless has less lead issues.
And the Amish, finding, doing a lot of that, and I go have to go fix it, because they did that exact same thing.
But you can see the lids on these are totally stainless, and the really small ones. And that's just the middle, but again, see the P here? That P right there means certified. It'll say if you're too certified, and if I take the P away, it's not the same paint, same submittal, just different dollar amount for certification. Again, compliant. So what you want me to do? You want me to go into your separators? We good? Okay, air separators today. These are the new 4900. This is the rage. Everybody has them. Armstrong, Bell and Gossett. This is called an air and dirt separator. This is the standard old style. And there's other ones. Now, what these used to do, they used to just change direction of water and the air would vent out. When you get into these new ones today, there's actually this basket of pawl rings with the ones with the removable, or these little pawl rings are actually full of inside of this. It looks like this. Different people use different things. We use these pawl rings, and what it does is it adds surface area. The more water contact with surface area, we get micro bubbles forming in the surfaces. We get micro air filtration, and it changes direction so much the dirt falls into the bottom of the unit. That's why they call it an air and dirt set.
Are those refillable?
Well, if you buy the ones with the baskets with the removable top, yes, you can replace that basket. But they're stainless, they're going to last forever. These are nice if you're going to put it on a system that's got exposure, like cottonseed. And you get this impacted with cottonseed, I can blow it down all day long. Unless you pull that out and take a pressure washer to it, you're never going to clean it out. The vast majority of them are sealed, and as long as they blow them down like every 6 months, you'll be fine. We also make Taco now has a handle on ours, comes with a magnet, and you can turn the magnet and it turns the magnet off so you can clean it. Turn the handle, the magnet goes back on. The reason they came out with those is years ago it wasn't a problem with most of our pumps, squirrel cage, there's no magnetic problems. Now in the world of ECM pumps, now they all have a permanent DC, a permanent fixed magnet. So the pump is always magnetized. And what happens is if you don't get the metallic out of the system where that magnet is, it's going to draw every piece of metal in your system right to that motor end of that pump and build it and build it and build it because it's magnetic. So we put this magnetic in front of the pump, so anything comes in magnetic, gets stuck in this magnet. I can turn off the magnet, flush it, and then so if you're using ECM pumps with permanent magnet, you've got to put it there. We make little tiny ones. We make just dirt separators. We make air and dirt separators. Everybody, all of them. Armstrong, everybody.
But that's where I was going with it. I was thinking more of like, you know, mud and that type of stuff that gets, I mean, you know, through
Well, that's what you gotta look at.
buildings and
If you got a lot of contaminant, I would recommend to go to the removable lid because that's the way to clean that. If you got really heavy stuff, they put one in when they first came out with it. They put one in somewhere in Florida. This thing was like a 36-inch one. They spent 5 days and they dumped it like 6 times a day, and you saw them with wheelbarrows of sand.
coming out of it.
That was all in the system that thing was taken out. It was crazy. But like 5 days they took sand out. So they do work. We have a little demonstrator and spelling guys that have them too. And we pump air into the city. You can see the air. We dump dirt in there and it goes around about twice. It's all in there. So it takes it all out. It really do work. And there's the removable basket. Like I said, these are the fall rings. Fireworks makes. They look like brushes, copper tubes with brushes on. And that's how they do there. And again, it's all about adding surface area and changing the flow direction. This whether you do it with a brush or you do it with our fall rings. This is called air and dirt, and they just increase the surface of it. And what happens is the air will stick to the surface. A little tiny air bubble will start amassing here, they'll put here. And then they'll go into a bigger bubble, and they'll finally release and go out. Where the normal just change direction, we'll never see that. They call it micro air filtration. We also make these. If you're ever doing a boiler system, these are slick. If you're going to do everybody know what a primary secondary boiler system is? Okay, if you have a boiler system, I can have my boiler go to a pump out to the system and back. Okay, there's one big loop. In a decoupled boiler system, what you do is you have your main loop. But on your loop, you put 2 T's and you pump out to the boiler and inject it back in. You have a space called a decoupler. It's bidirectional. So if I've got this big circle, these pumps are going this way. These little boiler pumps are pulling out and dumping back in to meet that. If I shut these pumps off, these little pumps are going this way into the big loop and just pulling water out. And see, if I shut those pumps off, it's actually going to pump and circle backward and that's the pipe. The main pumps are going this way, but if those pumps are up, I'll go backward. I can still run the boiler. I still have a path. The big thing of it is in my main loop, remember the BTU GPM 500 delta T? If I run a 20-degree delta T on my boiler, my main loop, I might be at 500 GPM. Most boilers will take a 30 or 40-degree delta T. I can run my boiler, which means I raise my delta T by twice up. It takes my flow down by half. So now I've got a 4-inch or 6-inch piping system. I might only be running 3-inch to my pump, my boilers. And I'm running half the flow to the boiler, higher delta T. But when it gets back in the main loop, it's all going to blend in and give me my 20 over here. I got 400 GPM over here and 20 or 200 GPM over here. 20-degree, 40-degree. BTUs, GPM 500 delta T. It doesn't care. But you can go get away with smaller pipes, smaller pumps, and unless the boiler do its own thing, and they totally don't see each other. When you do a decoupler, you want to keep it within 5 to 8 pipe diameters. And the reason that is they get too close, it wants to recirculate something. Too far apart, these pumps are going to build a differential and want to pump the boiler. Or if it's short enough, these boilers don't see each other at all. So we decided we came up with this. Instead of using the 2 T's, like I said, in your system, boiler loop comes in here. This goes to your boiler. The main system loop comes in here. This goes to your boiler. Boiler goes back to here. This goes back to your system. 40-degree delta T here. 20-degree delta T here. Okay, it doubles the flow. So if I got 400 GPM here, and 20-degree, I mean, I only need 200 here, right? If I come in here with 400, 200 goes this way, 200 goes this way. Whoop. Oh, no. 200 comes back in, goes back out at 400. Does that make sense?
Yeah.
Because it's all added. And if I do 300 that way and 100, 400, then I send 100 to the air separator. Now, if I shut these pumps off, it's going to go out, suck out 300, go out and come right back down to the air separator back to itself. And if I shut these pumps off, they're still going to go the right way. Maybe this when they mix in there, and what that device does is it fixes the thing in your T's. So you can't get that recircle built the differential, it's fixed. And it replaces the air separator. I can put the polar rings in that.
Oh, it's all in one.
Yeah, my air separator, my decoupler, all done in one. I don't have to put in 2 more T's. It simplifies it. And they're 125 pounds, 150 pounds, whatever you want to ASME. They're rated just like the air separator.
I mean, are they a lot more expensive than just standard?
They're actually really maybe 25 to 30% more than the air separator.
But you're
saving. It'll save you money in the long run, yes.
You get multiple boilers tying in, I tell you what, it just cleans up the pipe.
Oh, and it makes it easier for the control guys, because they're looking at the 40-degree over here and 20 over here.
Yeah.
Oh, it just makes
There's so much.
I'd never lay out a boiler system without doing decouple. You cost you 2 more pumps, but the headaches it takes away is just the only thing you got to be careful when you decouple a boiler. Make sure you've got enough volume on your boiler loop. If you shut off the main loop pumps, most boilers want a 5-minute run time. So if my boiler needs 20 GPM, I need 100 gallons of volume in that piping system. If I do the calc, I only got 30 feet of pipe instead of 300 feet of pipe, and I only have 60 gallons of water there. I may want to put in a 50-gallon buffer. So if I shut these pumps off and the boiler fires, it'll just go around itself so it heats that amount of water for 5 minutes till it hits temperature.
Yeah.
Otherwise, you'll short cycle your boiler because there's not enough water there, and you start tripping on that. And they do that with a lot of chillers as the buffer tanks, because the chillers now all have a runtime on it. And they want a minimum volume of water they can cool. So, and what's nice with the buffer tank, if I do put in the buffer tank, I have very light load. It's in the shoulder months. I'm not using hardly anything. My boiler's firing at 80,000, but I've got enough volume to run for 5 minutes. The boiler's going to shut off. Now my pumps are still pumping. I have all that volume of heated water. Now the system starts pulling off. Guess what? My boiler's going to take 15, 20 minutes to come on. I have to take all that heat out of that loop I build up in that buffer. You know, then when I get balls out, everybody's on equal, but during the light loads, the boiler will fire and heat that loop up, and then the pumps will just keep circulating until the loop drops, and the boiler say fire again. But you have all that heat in that buffer tank, in that loop, and have all that water to the top. Until I start bringing in enough cold water to temper it. The boilers will never fire until you dump that heat out of the system.
Yeah, one of the things that kills the newer boilers is the short cycle. You don't want to do that, so. Yeah, I'm gonna buffer tank.
Yeah, that's pretty much it. That was
the
big thing I had on there.
Well,
Off, but they.
Thank you, Jeff.
Oh, you're welcome.
Appreciate it.
Appreciate it.
See, we
But enough for you?
Something with this.
Appreciate it.
No problem.
We
How long you been?
that.
Oh, yeah.
Folks, you know.
That's about an hour.
Your bare pumps and kind of modulate and kind of
I can't see it.